Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. A formal troubleshooting methodology serves as the foundation for consistent, effective problem-solving in information technology environments. Rather than relying on trial and error, this structured approach guides technicians through a logical progression to identify, isolate, and resolve issues. It ensures that no steps are skipped, and it provides a repeatable process that can be used across different types of technical problems. For the A+ certification exam, mastering this methodology is essential, as it underpins nearly every troubleshooting-related scenario and question throughout Domain 5. The CompTIA A+ exam defines a specific 6-step process that technicians are expected to follow. Step 1 is to identify the problem, gathering all relevant information. Step 2 is to establish a theory of probable cause, drawing on prior experience and observations. Step 3 is to test the theory to confirm the actual cause of the issue. Step 4 is to establish a plan of action and implement the solution. Step 5 is to verify full system functionality, ensuring the problem is truly resolved. Step 6 is to document the findings, which builds a knowledge base and supports future troubleshooting. Step 1. Identify the problem. Begins with gathering information from the user and from direct system observation. This includes understanding what the user was doing at the time of the issue, what symptoms were observed, and whether there have been any recent changes to the system. Environmental factors such as temperature or electrical conditions may also be relevant. It is important to record all findings before making any changes, to create a baseline and ensure a complete view of the situation before moving forward. In Step 2, the technician uses the information gathered to establish a theory of probable cause. This is where experience, training, and known issues all come into play. The goal is to develop one or more hypotheses that could explain the observed symptoms. It is generally best to start with the simplest and most likely explanations before considering more complex scenarios. This step does not involve changing the system. It is purely analytical and forms the foundation for targeted testing. Step 3 involves testing the theory to determine whether it accurately explains the problem. This may include running diagnostic tools, checking logs, or observing system behavior after making a controlled change. If the theory is proven correct, the technician can proceed to the next phase. However, if the test fails to confirm the theory, the technician must return to Step 2 and reconsider alternate causes. This loop ensures that changes are only made based on verified understanding, not assumptions. In Step 4, the technician creates a plan of action based on the confirmed cause. This plan outlines the specific steps needed to resolve the issue, taking into account system dependencies, user impact, and any potential risks. In some cases, the plan may involve scheduling downtime, performing backups, or coordinating with other teams. The key is to ensure that the fix is applied in a way that prevents additional problems and restores system functionality as quickly and safely as possible. Step 5 is where the technician verifies that the solution was successful and that no other issues were introduced. This means testing not only the function that was originally affected, but also any related systems or services. If the issue impacted a user, the technician should confirm with them that the problem is resolved from their perspective. This step ensures that the fix has fully addressed the root cause and has not led to unintended side effects or regressions. The final step, document findings and actions, is critical for creating a record of the issue and how it was resolved. This documentation may include the original problem description, the root cause, the steps taken to resolve it, and any preventative measures implemented. Proper documentation allows future technicians to benefit from past experience and contributes to the organization's institutional knowledge base. It is especially important in managed environments, where recurring issues need to be tracked and addressed systematically. In real-world IT work, the 6-step troubleshooting process is used by help desk technicians, field service engineers, and systems administrators alike. It supports consistency across support teams and enables clear communication between tiers of technical support. Whether resolving a simple printer issue or diagnosing a complex server failure, technicians who apply the process methodically are more likely to arrive at effective and efficient solutions. In environments with formal service-level agreements, this structured approach is often mandatory and tracked through workflow systems. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Following the 6 troubleshooting steps in sequence is vital for ensuring thorough and accurate resolution of technical problems. Skipping steps, especially at the beginning or end, can lead to misdiagnosis, repeated failures, or even data loss. Even under time pressure, it is important to move through each stage methodically. Rushing through the process may yield temporary fixes, but can leave root causes unaddressed. Consistently applying the full methodology builds confidence in outcomes and creates a repeatable framework that can be trusted across varying levels of urgency and complexity. The methodology is designed to adapt to a wide range of issue types. It applies equally well to hardware faults, software malfunctions, network connectivity problems, and mobile device errors. Whether working in a physical or virtualized environment, the steps remain relevant. This flexibility makes the methodology suitable for troubleshooting issues with desktops, laptops, servers, printers, and mobile devices alike. Regardless of the platform, the process helps ensure that resolution is based on evidence, not assumption. Each troubleshooting step may call for specific tools that assist with diagnosis or resolution. Identifying the problem might involve reviewing system logs with Event Viewer, monitoring performance in Task Manager, or inspecting drivers in Device Manager. Testing a theory may include using diagnostic software or running hardware checks. Implementing a fix could require deploying scripts, installing updates, or restoring system images. Understanding which tools align with each step allows technicians to work more efficiently and gather meaningful data during each stage of the process. Poor troubleshooting habits can severely undermine the effectiveness of support efforts. One common mistake is jumping to conclusions without collecting sufficient evidence. Another is applying solutions from unrelated past issues without verifying that the conditions are the same. Technicians may also fail to fully test or document their fixes, leaving problems unresolved or poorly understood. Avoiding these habits and adhering to the structured process leads to more accurate resolutions and better outcomes for both the technician and the end user. In some situations, collaboration and escalation become necessary. A technician may consult with a team member or escalate an issue to a higher tier of support when the problem exceeds their scope or expertise. This typically occurs between Step 2 and Step 3 once an initial theory has been formed but cannot be confirmed or resolved with the tools or access available. Proper documentation of all findings and actions ensures that the next technician can take over without repeating previous steps or missing key details. Effective time management plays a role throughout the troubleshooting process. Some steps, such as identifying the problem or testing a theory, may take longer depending on the nature of the issue. Prioritization through triage helps technicians decide which problems to tackle first, especially when handling multiple requests. If the process is interrupted, partial findings should be documented clearly to allow for smooth resumption. Balancing speed and thoroughness is critical to maintaining both productivity and quality of support. On the A+ exam, questions related to the troubleshooting process often focus on order and decision-making. You may be asked to place the 6 steps in their correct sequence or to identify the appropriate next action based on a provided scenario. Other questions may present a partial troubleshooting case and require you to select the most logical step to perform next. Familiarity with the structure and purpose of each step ensures that you can navigate these questions confidently and accurately. Customer satisfaction improves significantly when technicians apply a structured troubleshooting method. Clear communication, predictable procedures, and effective resolution all contribute to a better support experience. By addressing root causes instead of just symptoms, technicians reduce the chances of repeat issues. Customers gain confidence in the support process, knowing that problems will be addressed thoroughly and systematically. In service environments, consistent use of this methodology reflects professionalism and enhances the reputation of the support team. The six-step process also supports preventative maintenance and long-term improvements. Analyzing root causes can reveal systemic issues that, once addressed, prevent future failures. Documenting solutions adds to internal knowledge resources and may prompt updates to configuration standards, training materials, or usage policies. These insights help organizations improve reliability, reduce downtime, and maintain more stable environments over time. Troubleshooting, when done thoroughly, is both reactive and proactive. In summary, the six-step troubleshooting methodology is a core element of the A+ certification and a standard practice in professional technical environments. It offers a reliable, repeatable framework for diagnosing and resolving a wide range of problems. Each step, from identifying the issue to documenting the resolution, plays a vital role in ensuring completeness and accountability. Whether preparing for the exam or working in a support role, understanding this process is essential for effective technical troubleshooting. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.